Before I get started, I want to say that I'm here on a mission. Not only am I trying to present stuff to you, but I want something in return. And I'll be describing what that mission is later on in my talk. There's actually two missions. The other mission is I am trying to spread the word about telomere biology as much as I can. Still, I'm surprised that 90% of everybody I talk to have never heard of a telomere. And I think telomeres are the most significant discovery in medical research ever. All right, and still, as the world's still just trying to catch on to what's going on. So I want to start off with a slide. We all know that 65 is the new 45. And these people have what appears to be a very successful anti-aging protocol. Okay, they look great, they're 65 years old, and this is everybody's perception of what successful anti-aging is. But when I turn 65, I have an entirely different vision of what I want to be when I'm 65. And that's that. So that's pretty much what I'm going to be talking about. That's what my research is all about. And I really believe that this is possible. And I believed it for a long, long, long time. But it's only in the last 2 years that we've had our best proof of concept that this is not science fiction. This is real. And what I want to do is I want to spend about 3 minutes just let you watch a news report from Diane Sawyer where she talks about some researchers at Harvard University using telomere lengthening technology. They've successfully reversed aging in mice. They've turned old mice into young mice. This has been my mission since I was 10 years old, to find something like that. I'm sharing everything I do. The scientists all over the world are doing research based on building on research that I did a long time ago. These scientists at Harvard succeeded at, for the first time in the history of the planet, of actually reversing aging, turning an old mouse into a young mouse. There's been quacks and charlatans been saying they can do this for 4,000 years, but it's never actually been done until now. Nobel Prizes have been awarded. The scientist, Dr. Rhonda Pinell, shortly thereafterwards was made the head of MD Anderson, the top hospital in the United States. So this is very exciting stuff being done by very, very reputable scientists. And I'm really excited. And you know what? This experiment suggested that we might actually reverse Alzheimer's. It's these mice, they couldn't remember how to go through a maze when they got old, but suddenly they could remember again, suggesting that maybe Alzheimer's isn't the loss of memory as much as it's the loss of access to memory. And so this is really exciting. I think Alzheimer's is a disease worse than death, and it'd be great if we could find some way to actually do something about it. These mice also had, when they got old, they couldn't sexually reproduce anymore. When they were restored to young mice, they were breeding more mice again. It was successful reproduction. So a lot of great things happen with reversing aging here. So the question comes now, do we have to age? Is there any reason why aging even exists in the first place? Well, I don't know. Did you know that there are life forms on this planet that don't age? Lobsters. They have no aging process, no detectable aging process. And it's only been in like the last 100 years that people have even been wondering, okay? Before 100 years ago, nobody cared. But about 100 years ago, people started saying, well, I wonder how long some of these animals will live. So they start just watching to see how long they live. And some animals just are showing no signs of aging. And lobsters are one of them. Well, why is that? Okay, that's a really important question. Why is it we're aging and they're not? What can we do to be more like lobsters? The same is true for tortoises, clams, some whales, some fish, some birds. These animals, people are really surprised they're not showing any signs of aging. Well, why is that? Also, our reproductive cells. Even though we age, our reproductive cells do not age. And that's why our children are born young. Because if our reproductive cells age too, and our reproductive cells I'm defining as the cells that are involved in making our sperm and our egg cells. And these cells are passed on from generation to generation. If you think about it, you came from cells from your parents came from cells from your grandparents, on and on and on. There's a lineage of cells that have been dividing for thousands and thousands and thousands of years. And you're just part of that. And these cells don't show any signs of aging. Why is that? That's what I actually was asking 20 years ago when I first got into telomere biology. Why aren't these cells aging? So I'm William Andrews. I am founder, president, and CEO of a company called Sierra Sciences that is 100% devoted to figuring out how to stop the aging process and reverse it in humans. We're located in Reno, Nevada. I have been in this business, I've been in the biotech business for 32 years, and I've been in telomere research for 20 years now. And I right now have 45 US issued patents on the stuff that I'm going to be talking about today. So I don't actually refer to it as aging anymore. I used to say I'm doing anti-aging research, but it's the scientists all over the world that have been following up on my research have been showing that practically every disease you've ever heard of is associated with telomere shortening. Not only do we have the potential of possibly reversing aging, we have a potential possibility of reversing everything and decreasing the chances of people getting practically every disease. So I don't call it aging anymore, I call it telomere shortening disease. Now here's a problem. Is it a disease if everybody has it? So a lot of people get critical of me saying, you can't call that a disease because that's normal. Everybody has it, so it's not a disease. Well, my answer is, when we cure it, you'll call it a disease. So until then, I'm going to keep calling it a disease because I know we're going to cure it. So this is something you've heard me say a lot of you at least. Bad things happen when telomeres get short. It's my message to everybody. There's nothing wrong with a long telomere, but there's all kinds of problems with short telomeres. And who here, raise your hand if you know what a telomere is. Okay, so there's a lot of people that don't know. So now I'm going to define what a telomere is so that you can get caught up, because it's a very, very important thing. So I think the discovery of what telomeres do is, I think, the biggest medical breakthrough of all time. And only bigger ones are going to come after this, through this telomere biology. So let's focus on this word telomere. To describe what a telomere is, we need to zoom in on a human being. And when we zoom in, we find that a human is made up of 100 trillion cells. And most of the theories on why we age say that we age because our cells age. So if we could find a way to prevent the aging of our cells, that would probably prevent the aging of us, ourselves. Let's zoom in even further. Inside every cell is a nucleus. And if we zoom in on the nucleus, we find that the nucleus contains chromosomes. Chromosomes are where your genes are. They give you some of us blonde hair, some of us black hair, make some of us tall, make some of us short. A chromosome is like a long shoelace, okay? But the shoelace is like a string of beads. And the beads are called bases. So a typical chromosome is about 100 million bases in length. Long, long string of beads. The telomeres are the very tips of this chromosome, shown here in yellow. Excuse me. And the telomeres are only about 15,000 bases in length, at least when we're first conceived. But when our cells divide, our telomeres shorten. And therein lies the problem. Every time our cells divide, our telomeres get a little bit shorter. And it's because of the lack of the ability of our cells to duplicate the very tips of the chromosome. So every time a new chromosome is made, it is shorter. When a cell divides, the new cells have to have all the same contents of the original cells. So everything has to be duplicated in the cell before the cell can divide. And when the chromosome divides, the chromosome ends up being a little bit shorter. Okay, so when we're conceived, it's 15,000 bases. Cells start dividing. When we're born, the telomeres have shortened down to 10,000 bases. Then as our cells start to divide even further, and we grow up, our telomeres continue to get shorter and shorter and shorter. And when they get down to 5,000 bases, our cells lose the ability to function, and that's when we typically die of old age. So let's go over that again. We are conceived at 15,000 bases, we are born at 10,000 bases, and we die of old age at 5,000 bases. This is the only clock of aging that's ever been discovered in humans. I can take blood from any of you. I can measure the length of your telomeres, and I can tell you how old you are. And more importantly, I can tell you how long it'll be before you die of old age, just from the length of your telomeres. And there's absolutely nothing we can do about this. Telomeres shorten at about 50 to 100 bases a year in the healthiest of people. No matter how healthy you are, you can't get it to shorten slower than 50 to 100 bases a year. There are things you can do to accelerate the shortening. Okay? Smoking, obesity, stress, all these things can cause the generation of free radicals and inflammation, which are known to cause accelerated telomere shortening. But we can do things about those. We can quit smoking, we can lose weight, we can meditate to reduce stress. All these things have been shown to be successful ways of actually decreasing the rate of telomere shortening. But that's what it's all about. We are all suffering from telomere shortening disease. I want to congratulate my colleagues that I worked with 20 years ago, Elizabeth Blackburn, Carol Greider, and Jack Stosack, for being awarded the Nobel Prize in Medicine for this research. They had been involved in the research for 10 years before I even got involved. And because of all the pioneering work, when people started realizing what a significant thing was occurring in this telomere biology research, the Nobel Prize Committee decided somebody needs to get a Nobel Prize. And they awarded the people that started it all. So congratulations to Elizabeth Blackburn, Carol Greider, and Jack Stosack. Now I was awarded second place for United States Inventor of the Year. Second place because that was the same year that the HIV protease inhibitor was discovered, and they got first place. And that was a very significant discovery. But I was awarded second place for discovering a way to prevent the telomere shortening. And that's through the discovery of this enzyme telomerase, which my team at Geron Corporation discovered in the mid-1990s. What this shows, the green squiggle line here is a DNA molecule, shown as a double helix. And telomerase is that factory-looking thing that binds to the very tip of the chromosome, and what it does is it lengthens the telomeres. So what I want you to do is I want you to think of telomere shortening as a ticking of a clock. Okay, so we got a clock. Every time a cell divides, the clock ticks once. Divides again, it ticks again. Divides again, it ticks again. So that's what's happening in our cells. It's a very accurate timepiece of aging. Now in our reproductive cells, the only cells that this enzyme is found in, the cells divide, the clock ticks, the telomerase pushes it back. Those cells divide again, it ticks again, the telomerase pushes it back, and again. And so we have actually found that when we overproduce telomerase in cells, it actually starts ticking backward in the other direction. And this is, as you'll see, how the mice actually got younger, by actually overproducing telomerase in mice and getting them to go younger. So, as I said, it's found only in our reproductive cells. And for this discovery, a lot of things happened. Popular Science did an 11-page article about me and my research just about 2 years ago. This is a man who would stop time. I was on the Today Show. I'm right now, well, maybe up until just 2 days ago, I'm in Men's Journal magazine. They're talking about my research in August 2013, but apparently some people have told me that the September issue is now on the stands. This is right after Celebration, Isogenic Celebration. I went to the airport, and somebody comes running up to me and says, "Hey, I found this magazine with you in it. Can I get a picture of it?" And so they took this photograph and sent it to me, so I thought I'd show that picture. I've been in several documentaries, one called Don't Grow Old, the other one called Immortal. Immortal actually won an Emmy. It's all about anti-aging research involved in a lot of different labs. Both documentaries include other science